This video is to record an example on a Math 1-to-1 assignment C, which deals with hypothesis testing, and number 25, which is about a chi-square test for independence. So here is the assignment. It's number 28. It says a researcher was interested in the relationship between major and mathematics. That's your major in a college and your mathematics score. He hypothesized that there was a relationship between the variables, academic measure and mathematics score. So he's hypothesizing, he's claiming that there is a relationship. So for this objective, the data is represented in the following table. You are given the task of testing this hypothesis by first completing the topic research question and the above objective. So here is the example. Topic, you can call it major and math score. For the research question, is there a relationship between major and math score, or is there an association between major and math score, or is math score independent of major? That's different with a paraphrasing the research question. And the hypothesis, the claim or the response without empirical data could be that there is no relationship between major and math score, that math score is independent from major. So that's supposed to be major there. So now the objective is to determine whether or not there is a relationship, whether or not there is an association between major and math score. So for this, data has to be collected. In the assignment, the data that was collected is presented in this contingency table. The students were divided into two majors, the natural sciences and the ones in the social sciences, and a test was given. The math scores were recorded and were grouped up into two main groups, those that scored less than 60% and those that scored at least 60%. So for example, this 40 says that 40 students from the natural sciences scored less than 60%. The 72 says 72%, 72 students from the social sciences scored at least 60%. Now in the example, these are the values, 47, 53, 20, and 80. So these are the observed values. So we are going to take a critical value approach, and for this we need the chi-square critical value, which is 3.841. So this has to be a chi-square test, because in the first step, we can use the research project and hypothesis testing document. The first step is to identify the appropriate chi-square test. So this is a chi-square test for independence. And the second step now is to state the null and the alternative. So for chi-square test for independence, the null will be the statement that there is no association between the two variables, that they are independent of each other. And the alternative will say that there is an association between the two variables, that they are dependent on each other. So no matter which part of the world that you are in, and you are doing a chi-square test for independence, the null must say that there is no association between the two variables, and the alternative must say that there is an association between the two variables. So for this example, the two variables are major and math score. So here it is that the null is saying that score is independent from major. That's one way of saying no association, and that happens to be the claim. And the alternative is saying that score is dependent on major. Yes, there's an association. So you can look at the null and the alternative as two persons debating. They are looking at two variables, major and math score. The null person is saying, well, okay, there is no association. I don't think that there is any association between the two. And alternative saying, are you sure? Are you certain? I think that there is an association between the two. So these are like two persons debating. Now, when two persons are debating, there must be a third person to intervene, because if you are left the decision on either one of them, they will always be biased towards themselves. So you need an impartial person, okay, a third person to intervene, and that third person must use a particular rule, a particular system, objective system in place to make a decision, an unbiased decision. Okay, so now that third person, now we can call that third person the test statistic, that are like a judge and a jury, and the rule that the person is going to use The rule that the test statistic is going to use, the system that it's going to use to make an impartial decision, is the distribution curve with the critical region and the critical value upon it. Okay, so this coincides now with steps number 3 to sketch the distribution curve, which will be a right tail curve skewed to the right for chi-square test. Step number 4, to shade the critical region. The critical region will always be on the right. So it's like a right tail test, but skewed to the right. And the critical value placed on the critical point. And this was done here. Okay, so that's the system that's in place. And it's an impartial system because the critical value was obtained from historical data, from tables tabulated, and it was obtained using objective means. Now, the critical region, that's where the test statistic or the judge or the jury will be saying reject HO, and the non-critical region, that's where the test statistics will say do not reject HO. So the role of the test statistics is to say one out of two things. So the test statistics will say either to reject HO if it ends up in the critical region, and if the test statistics end up in the non-critical region, it will say do not reject HO. So that's the system in place again. Anywhere in the world that you are doing a chi-square test for independence, critical value approach, the test statistics will either say do not reject the null or reject the null. And that's where the word null came out from, nullify. So either you nullify the null or you do not nullify the null, okay? Based on what the test statistics say. So therefore now, we need to calculate the test statistic so that we can use it to make a decision, either to reject the null or not to reject the null. And the way to calculate the test statistics is by using this formula, the sum of O minus E all squared divided by E. O stands for the observed values, E stands for the expected values. Now, the observed values are what was observed, the scores after the test is given. The expected values will be calculated using this formula. Row total times column total divided by grand total. Each observed values has the row total. Each observed value have the column total. So for example, 47, the row total for 47 is 100. The column total is 67. So it will be 100 times 67 divided by 200. The grand total is 200 because for this example, it's 200 students that were tested and grouped up into natural sciences, 100 of them, social sciences, 100 of them. And the calculation will be giving us what we call a chi-square, the expected values. So there are 4 of them. Each observer will have their respective expected values. So this was done. And then now we can proceed to calculate the test statistic by first calculating chi-square contributions. A chi-square contribution is O minus E all squared divided by E. So for 47 and 33.5, it's 47 minus 33.5 all squared divided by 33.5. The first chi-square contribution here is 5.4. This was repeated for 47, 53, 20, and 80. All 4 of them, and here when this was total, when the chi-square contributions were totaled, then you get the chi-square test statistic. So here appears now our judge, or you can say the jury or the referee. So a decision has to be made. How? We have to plot the test statistics on the distribution curve to see in which region it lands. Clearly 16 is more than 3. So 16 will be placed on the right side of 3, and there so happens to be the critical region. So this referee, this judge, this test statistic must see to reject HO. And that is the decision. The null was nullified in this example. 2 persons are debating. The null was nullified. It's like the judge say, well, null, your claim is not it has to be rejected. Okay, so it's not valid. So what we are left with the alternative. So the alternative appears to have won a little bit here, and it will be the conclusion. And that's what is stated now in the steps following. After you plot the test statistic on the distribution curve, you've got to make a decision. You reject the null if the test statistic is in the critical region. You do not reject the null if the test statistic is not in the critical region. By the way, there are two errors that can be made, type 1 error and type 2 error, because you can reject the null and it is true, but you can do not reject the null and then it happens to be false. But you'll only know if another person repeat the experiment or repeat the investigation, or you yourself have to repeat it to verify whether or not what you are deciding is true or not, okay? But at the moment, you may not know because you are very confident of your data that you have collected. Now, the final step now is the conclusion. If the null is rejected, then you're left with the alternative, it will be the conclusion. But if the null is not rejected, itself will be the conclusion. Always remember that you will start the test with two statements, the null and the alternative. After the test is completed, only one will be the conclusion. So in this example, since the null was rejected, based on the data, there is an association between. So it appears that there is an association. What type of association? You have to leave that for another research. Okay, so in a nutshell, hypothesis testing, you begin by stating what the two persons are saying, the null and the alternative, two persons debating. Then you set up the rule, critical value approach. That's your distribution curve with the rejection region. Okay, placed or defined by, okay, the rejection region and the non-rejection region is defined by the critical value. Okay, then we have to call up the third person to intervene, which is the test statistic, which has to be calculated and has to be placed on the distribution curve to see what, or to hear what it will say, or to see what it will say. It can either say reject the null or do not reject the null. Okay, that's the two things it can only say. Do not reject the null or reject the null. If it's in the critical region, it will say reject the null. If not, it will say do not. And then you decide, you write the decision that the test statistics said, and then you conclude with either the null or the alternative. The null if it was not rejected, the alternative if the null was rejected. And that's hypothesis testing, critical value approach. This example is a chi-square test for independence.